Maybe a few words to introduce myself. I'm Michael Kapinsky. I'm with Beckman Coulter Life Sciences since roughly 15 years now. And I'm Senior Marketing Manager for reagents, being responsible for the DuraClone ready-to-use applications in the research field. Today, I want to talk a little bit about DuraClone technology. So DuraClone is a proprietary dry antibody panel formulation of Beckman Coulter. And I would like to talk a little bit about how this antibody panel formulation will impact your workflows in immune phenotyping and functional assays. So before we look into the product formulation and the product offering, I would like to take a few words, high-level view on the utility of flow cytometry in cancer research. So what is it that flow cytometry can add to state-of-the-art translational cancer research? I think it will become quite obvious that we need higher complex assays to really use this utility in cancer research. So we have to go for high-content cytometry, which needs a certain level of expertise. And I think with the DuraClone panels, we can provide a tool that makes it really easy to implement higher content assays in your clinical research studies. I also, of course, would like to give a short overview of the portfolio that we have in the DuraClone program. So which are the questions that would be easily addressed by our ready-to-use solutions. And finally, of course, I would like to summarize and also give an outlook what will be next in DuraClone technology. So I think also during the last 4 days, it really became clear that there is a broad diversity of novel approaches in fighting cancer, where only a part of it is what we would refer to as small molecule therapies. As we see here in this summary of clinical studies or the drug pipeline, clinical studies related to the drug pipeline for multiple myeloma. So only half of it is small molecules, and the other half is what we could summarize under biologics and immunotherapy. And if we have a look at this specific compartment, we see that antibodies make the largest part here, of course, probably with the checkpoint inhibitors being really important, and also the ADCC-inducing antibodies. But also we see that cellular therapies, so therapies where the cell, mostly autologous cells of the patients are the agent, already rank second here, making up a fifth, basically, of those studies in the field in immune therapy. So I think this already puts a spotlight on the, on the fact that flow cytometry shall play an important role here. So what kind of therapies do we find in here? Most promising and most advanced, probably the immune checkpoint modulators, but as already said, also the immune cell therapy, other therapeutic antibodies, bispecific antibodies. We have vaccination approaches, we have modulation of other compartments, more systemic compartments of the immune system, and we have combinations. Although often, of course, this list is not exhaustive. Let's have a very simplified look at immune checkpoint modulation. So we basically will see upon exposure to an antigen-presenting cell, the activation of a T cell, and as this antigen is a tumor antigen, the T cell will try to attack the tumor. And of course, by this activation, we will also see that so-called checkpoint modulation molecules will be upregulated, and tumor cells and other cells may inhibit the immune response of the T cells by exposing ligands to this checkpoint modulation molecules. So I think it becomes obvious that knowing the profiles of the cells regarding the checkpoint inhibition molecules will play an important role here investigating these mechanisms. And this is a typical model application for flow cytometry, of course. Another example, immune cell therapies, the famous CAR cells, the CD19 CARs, that are equipped with a certain receptor, a chimeric antigen receptor that recognizes a tumor-associated antigen. And upon this, we have, activating domains in the T cell that will trigger cytotoxicity, that will trigger T cell proliferation, cytokine release, and other things. So also here, we have cellular properties that we look at. And we will be interested whether the specificity, the identity of the cell is also linked to function. And on the other hand, not only looking at the effector cell, we also would probably be interested in following up the tumor cells, for instance, here in this case, BALL cells or plasma cells or other entities, with our multivariate approach here in finding residual cells. Also a model application for flow cytometry. And as a third example, I have here the tumor microenvironment with different species of inhibitory cells that also could be very well looked at with flow cytometry, for instance, Treg cells, or for instance, neutrophils that express immune modulating antigens. So I think it became clear that flow cytometry can be a key tool here in this field of investigation. On the other hand, it becomes clear that we cannot approach this with very simple flow cytometry tools. We really need higher complexity panels. We need highly informative multicolor panels to do so, which typically require certain expertise to implement and to apply. And I would like to now introduce a little bit the DuraClone dry formulation technology with regard to its ease of implementation. So if we look at the development of high content assays, we will find a scheme like this, a scheme similar to this. So we have to select our antibody clones. Going from there, we have to select our dye combinations, so which antigen to pair with which dye. And having obtained the panel, we have to verify the panel performance. And each of these steps, including the verification of the panel performance, requires a rather high level of expertise. As we arrive here, we will see cases where the performance is satisfying, but we also will see probably with a higher likelihood in the first approaches situations where the panel performance is simply not satisfying. And this means we have to go back into this loop. Probably it could happen that we have to do this several times. A very time-consuming process. As the performance is acceptable, we will further have to optimize the preparation protocol, and to make it a real executable, reproducible assay, we will have to create SOPs around the preparation here, including the quality control of the cocktails. And only if all this is accomplished, we will have the possibility to transfer the assay into the lab. So a lot of expertise needed and very time consuming. And this picture is to show that while you're developing a new panel, you cannot just rely on what you already have. So what I've done here is showing two data sets. They both have the same clones, so 10 different clones, but I swapped the fluorochrome assignments to the different antibodies. So we just swapped the fluorochromes, except the antibody that is used for detecting this delicate population here. And you will see that on the left case, we have a very nice low detection limit, a fantastic resolution, while in the right side, where the same specificities are measured just using a different combination of fluorochromes, this population basically is lost. So we have taken the same clone here with the same label, a clone that we probably have a very good experience in the lab, where we thought we can rely on that, and now putting this well-known, well-beloved clone into a new application, we totally fail. So this is simply to illustrate that multicolor cytometry design is really a question of the full panel. You cannot just go by old school rules that may say, if you have a dim antigen, take a strong dye and avoid spillover. I think that is a very quick dead end in multicolor cytometry, and to design these panels is much more complex and needs to take into account the expression patterns and also the spillover patterns, and also some instrument properties play a quite crucial role here. So bottom line, antibody panel design indeed is an expert matter. Once we have the panel, once we have our cocktail prepared, we have our QC procedure set up, we can start in the lab. So we may mix the cocktail and we dispense the cocktail. We have the opportunity to do a lot of pipetting errors here and to bring in a lot of variability. We'll have a complex inventory management for a whole bunch of different single color reagents, and probably as these reagents come with different testing volumes, staggered expiry dates, and so on, we'll see complex inventory management and also a considerable amount of waste, so simply money that is lost. Not to forget, which is more important really here, the source of human error that we introduce. So what can the DuraClone solution do about this? What is the DuraClone solution? First, maybe to understand why it could eliminate these issues. What we have here are assays that are expert proven, so they are developed with key expert labs in their field, such as the one study group, which was a transplantation study. We have a lean workflow because the antibody panels are dried inside the tube in a unitized format per test. So there's no antibody pipetting necessary. We can just start by adding the sample. And this automatically implies that our inventory management will be a very simplified one. However, as instrumentation today is capable of measuring 10, 20, and even more parameters, these panels, despite the fact that they are highly standardized, still allow for a lot of flexibility. And I will show this during the next slides. The workflow is, of course, very streamlined after that, as we only have to add the sample. In case of whole blood or bone marrow samples, we would have to lyse and wash and acquire. There is, as I said, no necessity to pipette the antibodies. The format is unitized per test. The workflow is basically identical, regardless which assay I'm going to apply. And all this can be shipped and stored by room temperature, which is, of course, a strong positive implication for multi-color studies and also longitudinal studies. As you can share exactly the same antibody cocktails with your collaborating sites. You don't have to share SOPs, which may be executed with different diligence at the different site. You can really make sure by eliminating all this cocktailing and antibody pipetting process that all of the collaborators at any time point will use the same antibody combination. That is the look and feel. So you have these light-safe pouches where the tubes are in. These pouches either contain the panel tubes, the test size typically is 25, or they would contain the compensation kits. And the compensation kits have some special features I would like to dig into a little bit deeper. So the compensation kits, that means that each of the color is in its own tube, dried down, so same format. But especially for the tandem dyes, we have exactly used the same antibodies. So it's exactly the same lot, which automatically translates to exactly the same dye spectral properties. And as the dye format stabilizes the tandem dyes over time much better than you would see in a liquid format, you can really achieve a very accurate and very easy compensation procedure here that does not require an expert in the end to tweak on the compensation until it looks quite balanced. So if you now come back to the scheme of setting up a high-content assay for clinical research in your lab, you'll see that all these steps that consume a lot of time, that bind a lot of expertise, that repeatedly, as you have to repeat the cocktailing, of course, very frequently, consume also workforce, all this goes away by just using the DuraClone. So the panels are expert proven, ready to use, they come with an optimized preparation protocol, and cocktailing is simply just off the radar. You don't have to do it anymore. This introduces a lot of experimental rigor also in our DuraClone preparation protocols, as the whole procedure upfront of adding the sample is just eliminated. So we add the sample, we have our preparation procedure that, for instance, for whole blood could be to lyse the red blood cells and wash, and then we acquire the data, and that's it. So we have, of course, a minimization of staining variability and an elimination of error here. We will shorten the assay turnaround times, as simply the whole cocktailing procedure just falls off the radar. Thus, the assay availability will be extended. We can ship to our collaborators without any worries. And also, which may sound a little bit trivial, but it's important, your staff just can do an assay quickly in the evening without pulling 20 antibody vials out of the fridge, starting to cocktail. You just take it out of the drawer at your bench and start the preparation. Very quick and easy. You can leverage what other experts already have been working on, so you don't need to reinvent wheels again. And all the assays are tested also for whole blood, so there's no need to isolate PBMCs if not from an experimental standpoint this is necessary for you. So what is the product offering that comes in this format? We basically have three branches here: the immune monitoring, immune system research branch, immune function, and rare event detection. This is an overview over the RM panels. 6 panels are targeting here adaptive immunity, T-cell tubes, B-cell characterization, an overview tube, a dendritic cell tube for PDCs and MDCs, TCR subtyping for the gamma delta receptor, a Treg tube, including Helios 45RA and CD39 characterization. Furthermore, a tube for innate immunity, a granulocyte tube that also allows to characterize the activation status of the granulocytes, and a very easy to use Swiss knife tube for counting, which is a no compensation, no wash tube, just counting leukocytes and viability. So let me put it a little bit provocative. You have a flexible standard here, which of course is a little bit contradictory in itself. But what it really means is that you have a very nice 10-color IMT cell subset tube, for instance, that shows the exhaustion receptors, the terminal differentiation, the full naive effector memory, central memory, RA positive cycle. And just by adding 3 more markers, you would add also the stem cell-like T cells memory type to that. So you have a 13-color characterization of your T cell compartment by just 3 pipetting steps. Next example would be the granulocytes. I think what we achieved here is a very, very, very robust, really unbreakable gating strategy to subclassify the granulized subtypes and further pull out the monocytes. And here we have activation markers of granulocytes and also immune regulatory PD-L1 expression on the granulocytes, all implemented in the panel. So this is all you get without a single pipetting step. And if you want to look further at the monocytes, for instance, for HLA-DR expression to identify the MDSCs, you just add 1 marker, and here you are with the MDSCs. Next one, regulatory T cells, 8 markers showing the FOXP3 positive cells and characteristic marker of certain subpopulations. And also here you can add markers like granzyme B, for instance, to see the immune mechanism that the Tregs work by. The immune functional assays, here we have pro-inflammatory T cytokines and also T helper cell subsets by signature cytokines for Th1, Th2, Th17. I think the really impressive power of the cytokine cytometry stains lies really in the single cell level that you are looking at, and at the same time you see the amplitude of the reaction and the profile of the cytokines as segregated for each cell. So here's an example for a CAR T cell experiment. We again use 6-color standard. This 6-color standard allows the T cell classification as well as interferon gamma, TNF alpha, and IL-2 expression. And just by adding an anti-CAR and a smoking gun, we will see that this function is associated with the CAR expression, and the amplitude of the function depends on the spacer that we are using for this CAR. And on top of it, we have a surrogate marker for cytotoxicity implemented here. IFT helper cell is just a new one that comes out to the market this month. So this is about the Th1, Th2, Th17 subtyping of the T4 cells. Again, having some crucial slots open to really have a broad variability of commercially available markers that you can put in here, such as PE. I think this is maybe the marker that is most popular, the label that is most popular overall. The RE panels are a little bit different as they now look into the target cells and not the effector cells. So here we can offer mature CD5 plus B cells, detection of mature CD5 plus remnant cells, abnormal plasma cells, and also abnormal B progenitor cells. Here are the 3 panels that basically follow current guidance to the guidelines. What really makes it different as compared to the immune monitoring panels is the fact that we are looking for very small populations here, like 1 in 100,000. And so the DuraClone kits have been dosed here with regard to the antibody doses, really in order to accommodate a large sample volume or a largely enriched suspension of cells. So these are 3 examples for the multivariate analysis of the rare events here. This is a CLL example, this is a myeloma example, and here we have a BALL example. The radar plots here shall demonstrate that only a good composition of several highly discriminative markers would really bring you to your goal, to your objective, to have a very clear-cut discrimination of abnormal cells from normal, even if the population that you are looking at is a very, very rare population. I think with these panels it becomes especially obvious that flexibility or that a flexible standard is really needed, as many of the targets of novel immune therapy approaches would, of course, target antigens that have a high expression on these target cells and that typically would be used for identification or characterization. So here you really need alternatives. For instance, in case of a CD38 therapy, you would need some drop-ins like SLAMF7 or CD48 in order to clearly identify your target population that normally would be seen with CD38, but in case of these kind of therapies may be hidden with a masked epitope. I've been talking about high sensitivity, so here just to give you a short glimpse on the number of leukocytes that these antibody combinations, or the volume that these antibody combinations could easily accommodate. And also we have implemented some cutting-edge markers, I think, that become more and more important when looking at these rare cell events. With the ALB, we have taken care for open PE and APC slots, so I would say there is unlimited offering in the market to combine this with other markers. Okay, to summarize that, here's an overview over the whole DuraClone portfolio, which separates into the immune monitoring panels, the immune function panels, and the rare event panels. And the next step that we are looking at is not only to have dry cocktails for the antibodies, but especially looking at the immune functional assays that are always looked at with a certain reservation because they are believed to be too difficult to make reproducible. We are now introducing dry stimulator mixes into our program. These dry stimulator mixes will make cryopreservation, aliquotation, freezing, thawing, diluting, pipetting. All these things for the stimulators will just be eliminated. And with elimination of these steps, of course, the sources of human error and variability that are associated with it will also be eliminated. We will see the same unitized format, ready to use, just add your sample. Again, of course, shipping and storage at room temperature. So very easy to share with your collaborators. You're not only working with the same antibody panel, but you're also working with exactly the same stimulation. How will this impact the workflow? So typically, protocols work with PBMC preparation, a first very variable step. Then liquid antibody cocktails will be used. Liquid stimulation cocktails will be thawed from the freezer and will be diluted and aliquoted. And then we'll see a classical fix and perm procedure with several centrifugation and washing steps in between surface and intercellular staining steps. And our idea is really to step by step take out all these variabilities, optimize it for whole blood so that it's not necessary to do PBMC preparation, eliminate antibody pipetting, eliminate stimulator pipetting, and with the Perfix and C permeabilization kit, we are also capable to doing intercellular and surface staining in a single step without any washing or centrifugation steps in between. And I think it becomes quite obvious that this all will reduce the risk of variability and error considerably. I hope I could show you that the DuraClone format and also the dry stimulator format really accelerate the implementation of assays of high country flow cytometry applications in your lab and provide, despite it's a highly standardized, still a very flexible tool. All of this is expert proven. It is kind of obvious that taking pipetting out, taking aliquotation, freezing, thawing, centrifugation out of it, you reduce a lot of sources of error and variability and assure that you have a setup that is really rigorous, that allows to transfer assays to other places and operators, but still, also due to the increasingly powerful instrumentation, flexibility is not lost here, not at all.